Okay, let's continue. So now this will be the third part of the decision trees part B. And we're almost done with the example. Let's move on to the example. Let me share my screen. And this step one. Okay, here. So now we have this example, and we mentioned that the biggest information gain in this case here, okay, the biggest information gain is this windy. Okay, so that means that for this node, we will choose windy as our next node, as our next layer. So now let's put. I think it's good. Always good to have an example. Okay, we'll just move here, yeah, so that we can see. Okay, and then another, because how many things are windy? How many types of windy? In this case, 2, right? And we're only looking at this table. Okay, true or false, windy. So windy equals true. Okay, that's one. And then the other one is windy equals false. Okay, that's the next type. Okay, then the question is, I finished the video already. Okay, let me, I cannot. Hey, okay, then let's continue annotation. Okay, just that one. Okay, so windy is false. And then for windy is true, how many is the output? So windy, true. No, there are 2 no's and 0 yeses. Yeah, for this table. Okay, so 0 yes and 2 no's. Okay, and then for the windy, that is false, 3 yeses and 0 no's. Okay, so as you can see, there's no need to split anymore. Okay, once you reach there, that's the leaf already. So that means this one is okay, this layer is okay for that particular outlook, overcast, and in this case the windy is also okay. Okay, now we look at this one on how we're going to split it. So that means it's given 3 and 2 windy, I mean outlook of rainy. It's just if it's windy. If it's not windy, then definitely it will go for tennis. It doesn't matter what temperature, what humidity. Okay, if the outlook is rainy and it is windy, okay, if the outlook is rainy and it is windy, then definitely it will not go. It will not play tennis. Do you understand? Okay, play tennis is no. Okay, if it's rainy and windy, definitely it doesn't go for tennis. But if it's rainy but not windy, then definitely it will go for tennis. So that means it's the wind that really matters for this person. Okay, because of course the rain does not matter for him. Okay, wind will affect the ball, the movement of the ball. Okay, so this is how we check this table. Okay, for this particular node. So now for this node, you can do on your own and compute this table. Okay, and see which one will be the next layer. Okay, then we can do, for example, if the next layer, okay, so if the next layer is again windy, I don't know whether it will be windy again or humidity. So in this case, humidity high or normal. So maybe here you'll have humidity high or normal like that. Or if it's windy again, it will be like that. Okay. Okay, then we continue until you have a definite answer or a definite classification or decision of a yes or a no, or it may be one, in the other case, one on one, and then you cannot split them anymore. Okay? So now, the question we have to answer now is that we know already how to choose the layers, the more priority layers, and so on. As we make more layers, then we consider only that part of the graph, okay, for the next, for the subsequent layers. We don't consider the entire graph because, you know, when you're using the node, for example, either Outlook and Ready, we only look at this part, okay? And Outlook and Sunny, we only look at that part, not the entire table, okay?
Sir,
Yes.
we have a problem with the password, sir.
Oh, you have a problem with password. Which
the meeting
password?
Yes, sir. The meeting password.
Oh, okay. Let me check. Okay, let me stop sharing. I didn't give you the correct password.
Yes, sir.
Yes, sir.
Why?
Why?
Ah, it's a B. Okay, there. I forgot because it. Okay, sorry. Yes. Okay. Sorry. Okay, let's continue. So we share screen of the desktop. Okay, and view as a presentation. Okay, now we are done with this one. I think we understood it well. And then now the question is, when do we stop? Okay, so when do we stop? When do we say that we don't split anymore? That's the question, because we know already how to split, how to make layers, and all these other things. And where once there's a decision, in this case there's a decision, we stop. But what are other cases that we stop as well? Okay. So now, for example, if this is a fuel efficiency example, and we look at again the parameters, input parameters of cylinders, displacement, horsepower, and so on, and we output with a good or bad miles per gallon. So now the root layer is you have 22 bad. In this case, the blue is bad and good is red. Okay. Normally red should be bad. Okay, anyway, so there are 22 bad and 18 good miles per gallon of cars, models, and everything that we don't know about. We are going to, from the data that is given, now we are going to take all the other layers for us to decide whether the prediction, I mean the decision, or the classification is good or bad, okay, of that particular car. So in this case here, the cylinder, okay, it's just given to us. So maybe the computation behind it, we're not considering, but just given to us like this. So the first layer is chosen as cylinders. So in this case here, cylinder 3, 4, 5, 6, and 8. Okay. And in this case here, we predict bad. Okay. Well, it's actually with no prediction. I mean, nothing, because there's no yes or no. Okay. Decision, or good or bad decision, because both of them are 0. Okay, so in this case here, it predicts bad because always there's a there's a 1. The number of information, there's more leans towards the information here. The number of vehicles is lean towards the bad than the good. So 0 good. So this one we stop here. Here with 6 cylinders, by knowing just 6 cylinders, definitely it's bad and that's not good. In this case here, predict bad. Okay, there are more bad than good. Yeah, but probably we still need to split this one, and we need to split this one. So this we don't need to split because there's already definite answers. Okay, the question is, when do we stop? Okay, so don't split the node if all matching records have the same output value. Okay, so in this case here, there's a definite answer already. This one, and that one. Okay, so the one that we split is this and this. Okay, if you compute the information gain, this one will be zeros, and this one will be greater than 0. Okay? Excuse me. So now we continue. So we continue, and until you get into the full tree. So in this case here, everything is already, so if we just look at the picture, the cylinders was split into maker, okay? So maker, and then cylinder 4 split into maker, and then cylinder 8 split into horsepower. It didn't show here at the back, okay? Anyway, it split into horsepower. So for cylinder 4 split into maker, this is definitely good, okay? So no need to split. This one still needs to split, and this one still needs to split. Okay, that's why there's additional split here into horsepower, additional split here into acceleration. Okay, so here, no more split, okay, always good. Here still need to split. This one is 0, no need to split. So we split only this one. So until this one bad, this one nothing, and this one 1:1. Okay, no need to split because even this one, if they are identical and you cannot expand further. Okay, you cannot split the one. Yeah, it's just one good and one bad. Okay, you cannot split further. So now, if you compute again, this is the information gain will become 0. Okay, so here, if you say here the cylinder is equal to 8, again we split. Okay, so this is how you split. So eventually, in this case here, we predict in this particular branch, we predict the always good, and this is bad, and this one nothing. So in this case here, they say if we all 0, always predict bad. Okay, I don't know why. Okay, so that's the case when you stop when you stop computing. When do you stop computing? So in this case here, they say it's not anymore expandable. You see, if you compute information gain, there's nothing. It will always be 0. Okay, if you compute the information gain of others with definite answer, it will also be 0. So no need to split. Okay, or no need to branch out. Okay, so decision stamp. And they still have recursive. You have to recurse this one, and this is the full tree now. Okay, so again, this one was hidden, so we can look at this one. Oh, this one it didn't. Okay, this one no need to split because this one predict bad for 0, 0, predict good, and this one okay. This branch stopped here, so only here is the one that continues until finally it goes to here. Okay, so that's the decision tree. Any questions? Any questions? Okay, let me stop sharing and see. Wow, you have a question? You understood everything?
So I joined the meeting late due to the password, so I don't know what to say.
Oh,
So
only a few minutes, only less than 2 minutes.
So, but I have to watch that part again.
Okay.
Yes, sir.
Here's a question. More coffee? No questions.
So,
Yes.
what if are there cases where you won't get a 0 or a 1, or where you won't get a definite answer of if it's true or false, and
Yeah.
the decision tree continues, always continues? How do you stop it?
Yeah. Well, yes, it will continue, but as you split, the question of Mr. Tiboho is whether is there a way where you just continue splitting and splitting and it doesn't end. Eventually, it will end because there's no more data.
Okay.
As you split and you split, there will be lesser and lesser data to consider. As you can see in the table, you select the sub table, yeah, becoming smaller and smaller until finally, maybe in the last part, you only have 2 cases or 2 instances of yes or no, or good or bad. So definitely it will stop, yeah. But then when it will stop, when it will become, it depends on, that's why part of it, when you use the information gain, your decision tree will have lesser branches. Okay, it will stop. It will be a more efficient way of, not letting more branches to flow, so that, it will stop when there's already a definite answer. So as you can see in one layer, as in the example, using information gain, it will give us, it will shorten the answer. So in this case here, for example, here, so choosing cylinder as the first layer, there are already 3 instances that we stop. Okay, we continue only 2, but even here, when you stop here, you continue here, the next layer you stop. Okay, so the use of information gain will help you to have this kind of scenario for a tree. If you don't use it, most likely, if for example, if you choose, I don't know, horsepower, for example, if you choose horsepower, maybe all of them, we still have to split everything. Then it will be a lot of work for us. And it's not just a lot of work for us, but when you use the tree, it will be more, it will need more computation. The same as the Boolean tree that we are mentioning about. That depending on depending on which node you choose, then the tree will become much more complicated or much more simplified.
Okay. So, sir, if you have, if you come to a point where all the nodes have the same IG, which one do you pick? Do you pick randomly or?
Yeah, that's a good question. Yeah, it can come to a point where you have the same IG. You just choose which one. Yeah.
Thank you, sir.
You're welcome. That will be 2 points for lab number 4. Okay, remind me. Mana,
Yes,
you seem to like also 2 points. Huh? Any other questions? Ito Meleng.
So, sir,
Yes.
there are no complex problems using this decision tree. You're always gonna get a definite answer.
Yeah, one thing is you will not, there are cases where you don't get a definite answer, just like that 1-1.
Okay.
Yeah.
All right.
Or 0-0, And so you choose, in this case, they choose that if it's 0-0, it's a bad. Yeah. Maybe it's better, you decide, it's a better, it's a better decision. It's a better opinion to say that it's bad. Where it's bad, if it turns out bad, then you're okay. If it's bad and it turns out good, well, the person will be happy. Yeah. But when you say it's good, but it turned out bad, that person will be mad at you, So you choose, you just say bad. According to me, it's not definite. So maybe bad is the safer answer.
Okay.
Okay. Any other question? Mr. Tibuco now is the substitute of admire. Any other questions? Ramokate. The password, yeah? No questions? Okay. Just have 2 more minutes. So next meeting, I already uploaded the lab question for Boolean function. And then I will upload another lab exercise for this second part of the decision tree where you have to compute the information gain. Okay, so you're free to discuss with your friends, but please work on your own. Okay, so that these lab exercises are for you to prepare for the long test. So then next meeting I will discuss Bayes rule, and then we'll be ready one more lab, and then we'll be ready for the long test one. Okay. Okay. So Onili, why are you smiling? You want to say something?
No, sir, I don't want to say anything.
Where's the Rasta guy? He didn't come back. Daniel.
I guess they had a problem with the password, sir.
Okay. Anyway, yeah, it's my mistake because the password was not nice and it was a little bit vulgar at the end. So Okay. Yeah. See you guys. See you. It's good. Our attendance in the class is good. And the same thing as I mentioned in the messages, that the lab exercises, I check lab exercises based on your submission. So if you submit lab exercises on time, then the attendance is 1. If you submit the lab exercises late, then it's 0.5. Of course, no submission will be 0. Okay, that's what it is because we're doing online. Okay? Okay, thank you and see you next meeting. Bye.